Okay, section 1.6. 1.6. Now we are subtracting real numbers. All right, and the way we want to try and think about this is I prefer to turn everything into an addition problem if possible, especially when we start. So the idea is this. If I gave you something that's relatively easy, 9 minus 7. Okay, most of us know 9 minus 7 is 2. But if I change this into an addition problem, so what I really want to do is I want to say that's 9. Oh, why isn't that working? So what I really want to think of this is 9 plus negative 7. So what I'm really doing is I'm taking a subtraction and I'm making it into an addition problem by saying I'm going to add or change that the opposite of whatever this number is. So it's 9, make that a plus, and then the opposite of 7 is negative 7. And you should see that 9 plus negative 7, go 9 spaces to the right, come back 7 spaces to the left, is the same thing as 2. So really, when you are subtracting, and I'll say this over again, you are going to add the opposite. We're going to change the subtraction to an addition, and then change the sign of whatever's here. So we're going to add the opposite. So in general, if I have a minus b, that's the same thing as a, change that to a plus, and then negative b. So a plus negative b is the same thing as a minus b. Add the opposite. Okay, let's do an example or two. So we're going to do negative 13 minus 4. 5 minus negative 6. 3 minus 6. And negative 1 minus negative 7. All right, negative 13 minus 4. We're going to change this. Whoa, what happened? What the heck? That is super weird. All right, I'm going to have to pause this and find out what's going on. Okay, I have absolutely no idea what was going on there. I wasn't even touching the screen, and the whole thing was writing as I hovered over it. That was really strange. Okay, negative 13 minus 4. First thing I want to do is I want to create an addition problem out of this. The first number stays the same. That's our starting point. So it's minus 13. I'm going to change this to a plus, and then I'm going to add, so kind of ignore the fact that that was there. I'm going to add the opposite of 4, which is negative 4. So what this is really saying is I'm going to start at negative 13, and then I'm going to go 4 more to the left, which is going to put me at negative 17. Okay, let's change the second one into an addition problem. So it stays 5. Change this to a plus, and then the opposite of negative 6, which is 6. So what that is just 5 plus 6, which is 11. Add the opposite. So we'll start at 3. I'm going to change the minus to a plus, and then the opposite of 6 is negative 6. So going 3 to the right to start and then coming back 6 to the left is going to put me at negative 3. And then the last one, starting at negative 1, change the minus to a plus, and then the opposite of negative 7 is positive 7. So we'll start 1 left, come back 7 to the right, and that puts us at positive 6. So the whole idea behind subtracting real numbers is really just adding the opposite. All right. The same thing can be done using fractions, so I'll just do one quick example. I'll call it E actually. With fractions, negative 3/10 minus 5/10. Again, change this to an addition problem. So we start at negative 3/10. Now I'm going to add the opposite of 5/10, which is negative 5/10. So if I start negative 3/10, I go more to the left by 5/10, I'm going to end up at negative 8/10. That can of course be reduced to negative 4/5. All right. It could be given to us in word form. That's 2 actually, sorry. It could say subtract, what are we going to subtract here? 8 from negative 4. The importance here is that it's telling us to subtract, so we know how a subtraction problem, but it says subtract 8 from negative 4. The word from indicates that we're going to start with the negative 4 because I'm taking something from this. So we'll start with negative 4 and then I'm going to subtract 8 from it. So the order there is important. So the vocabulary here is the actual word from. All right, so we're going to change this into an addition problem. Starts at negative 4, change the minus to a plus, and the opposite of 8 is negative 8. So if I go starting 4 to the left and I go 8 more to the left, I'll finish at negative 12. All right, we can try some examples with multiple, not just 2 numbers, but with multiple numbers in it. So let's try, let's see, negative 14 minus 8 plus 10 minus negative 6. So I want to change all the subtractions to an addition problem. The plus here in the middle, that plus 10, that's already addition. I don't have to do anything with it. I'm going to change that minus. I'm going to change that minus into an addition problem. So minus 14 is where we start. That's the only one that we're not changing. That minus here becomes a plus. The opposite of 8, which is negative 8. This is already addition. We leave it addition. And then I'm going to change that minus to a plus, and then the opposite of negative 6, which is positive 6. Now everything is an addition problem. So we can go left to right. If I start at negative 14 and then I go 8 more to the left, that'll put us at negative 22. And then if I have negative 22 and go back 10 to the right, I'll be at negative 12. And then from negative 12, if I go 6 more to the right, I'll finish at negative 6. All right, let's try another one. Let's do negative 15 minus 2 minus negative 4 plus 7. So again, we're going to leave the 1 plus sign. That's going to be fine. We're going to leave that alone. I'm going to change these 2 subtractions to addition problems. Again, if there's a negative out in the front for the first number, it doesn't change. It's just where you're starting from. So it's negative 15. Change that to a plus. The opposite of 2 is negative 2. Add the opposite. Add the opposite of negative 4, which is positive 4, and then bring down the plus 7. Now we have all additions. So negative 15 and then negative 2, so 15 to the left, 2 more to the left is negative 17. Negative 17 is 17 to the left, and then I'm coming back 4 to the right, which will put us at negative 13. And then if I'm at 13 to the left, I come back 7 more to the right, we'll finish at positive 6. So again, and I'll keep saying it, the concept of subtracting real numbers is adding the opposite. It's the same exact thing. All right, so let's put this together with some slightly longer examples. And specifically, we're going to have grouping symbols involved as well. So we'll have negative 3 plus bracket parentheses negative 2 minus 5 minus 2 and the bracket. So I have parentheses within brackets. So grouping symbol within a grouping symbol, I must do this one first. I'm going to change it to an addition problem. So negative 2 plus the opposite of 5, which is negative 5. So we'll finish this part. Negative 2, 2 to the left, and then 5 more to the left is negative 7. And now what I have is another subtraction problem in here, so I'm going to change that to an addition because I've got to finish off the bracket first. So we'll have negative 7, change that to a plus. The opposite of 2 is negative 2. So inside this big bracket, I've got negative 7 plus negative 2, again 7 to the left. 2 more to the left is at negative 9. And then all I have left is an addition problem where I have negative 3, so starting at negative 3 and then going 9 more to the left finishes us at negative 12. Alright, all the order of operations are going to still hold true. If you have exponents, those come before multiplication division. If you have multiplication division, those come before addition and subtraction, remembering to work left to right. Okay, so we'll do one example where, extend this page a little bit, one example where we're evaluating an expression. So I'm going to give you some values. So given x equals 2, x equals 2, and y equals, let's go with negative 5. We want to evaluate x minus y divided by 12 plus x. And remember, that means we're going to substitute 2 in for x, and we're going to substitute negative 5 in for y. Here's the biggest thing when you're evaluating with negative numbers, and we hadn't covered this yet. If you're evaluating something that's negative, when you substitute the negative in, you want to put it in parentheses. If it's not negative, you don't necessarily need a parentheses like with these 2's, but since the 5 is negative, we're going to put it in a parentheses. That way we don't lose this extra negative. Sometimes people just write that minus down, think, oh, the minus is there, and just put a 5, and that ends up being wrong. So we're going to change the top of this to an addition problem. 2 plus the opposite of negative 5, which is 5, over 12 plus 2. And again, you might be tempted to try and cancel these 2's out here. That doesn't work because these are being added together. They are not factors. You can only cancel if they are factors, meaning multiplication. When it comes to addition, it doesn't work. So we're just going to simplify the numerator. 2 plus 5 is 7. Simplify the denominator, which is 14. 7/14 reduces to 1/2. Okay, there's an evaluation problem. All right. One of the last concepts that we're going to talk about, the only reason I'm actually going to mention is because it's in the book, and if it shows up on the final exam, I have to at least make sure that you guys have seen it. I will not put this on any of your tests, so don't worry about that. But it is in the book, so I'm going to go ahead and show it to you guys. And I slightly understand why it's in this section, just because it has to do with adding and subtracting of real numbers. So we're going to talk about a little bit of geometry here. If I have a right angle, which is what this is, it means the right angle is 90 degrees. If I were to cut that right angle someplace, doesn't exactly have to be half, so whatever this angle is, it's x. Whatever this angle is, it's y. If I were to add x and y up, it's going to give me 90 degrees. These angles are what are called complementary angles. Complementary angles. That's any two angles that add to 90 degrees. Complementary angles, any two angles that add to 90 degrees. So in this case, x plus y, because this is a 90-degree angle, add up to 90 degrees. X and y are complementary. So the question might be something like, well, what if I gave you one of them? What if I told you that y equals, we'll just keep it simple, 40 degrees? Well, the concept is pretty simple. If you know that y is 40 and they both add up to 90, then what I have is x plus 40 has to add up to 90. Well, in order to solve for x, we're going to subtract 40 on both sides. So x equals 90 minus 40. Now it's a subtraction problem. And this is a relatively simple one. You probably don't need to change it, but you could change this to an addition. 90 plus the opposite of 40. So 90 to the right, 40 back to the left is going to put us at 50 degrees. Okay, again, that was slightly more intuitive. I'm sure you could have just pretty much taken a look at the idea here and said, oh, if one's 40, the other one's 50 because they have to add to 90. I get that. But it's the concept that we can still do the same process for an application. There's one more type of special angle that's mentioned here, and it's what's called a supplementary. Supplementary angles. This delay is killing me here. And supplementary angles, we're not going to actually do an example of this, but the idea is that supplementary angles are any two angles yuck. Any two angles that add to 180 degrees. So 180 degrees is straight across. So if I've got two angles, one angle here, the other angle here, these two angles, we'll call this one x, call this one y. X plus y here would have to add up to 180 degrees. Basically the same concept as the complementary, but supplementaries have to add up to 180. Other than that, that's all the geometry that we're going to do for this section. So you should have enough now to complete 1.6 and the homework involved there.